You remember sign diagram, this? Remember the idea of sign diagram? Okay, this. Confirm please if you remember this. Yeah, so that is the key point that we need. So I'm just going to go through it with the way it is in the book. Now, we all know what inequalities are, but this time around we're dealing with quadratic inequalities. So maybe we'll start by writing how we want to go about it. Okay. Today is 22. So we'll be able to start with sign diagram and use sign diagram, okay? I'm going to quickly skip that so we can, because I don't want us not completing this today. I want us to actually complete it today. Okay. So we remember the sign diagram. We're not going to waste time. So for this, for example, just to remind us how sign diagram is done, sketching this means that these are the intercept -2 and 1. That's what you have, right? And because A is positive, it is a minimum. It's concave upward. So that means it comes with minimum points, right? Then if you look at it, so the sign diagram shows the y values, the position of y values within interval. So for example, from -2 to the left, the y values means where is the curve going? It's positive. Can you see that? Okay, that's why you have positive here. Now within -2 and 1, the y value is always negative. That's why you have negative here. Okay, and from 1 and above, okay, can you see my cursor? Okay, from 1 and above, the y value remains positive. So this is the sign diagram for this. Okay, if you have a curve that is in form of a maximum, because that is not here, so let's draw that ourselves. Let's just play around with it. So if it was in this case, okay, and this is maybe A and this is B, so the sign diagram will come with A, B, like that. So here will be negative, here will be positive, here will be negative. Do you agree? Something like that. Okay, so let's see. Now this is for a curve that does not touch. Okay, this is for a curve that doesn't touch. So you can have a point that touches, that crosses, that doesn't touch, and that touches. You know, those are the three possibilities you can have. And of course, each of them can come in two forms. You can have the maximum of this, you can have the minimum of this, you can have the maximum of this. Do you understand that? So these are the three possible categories that you can have. Okay, but remember, when A is positive or negative, each of these can be in two forms also, making 6 altogether, but in 3 categories. The first category is where it crosses at 2 points, where it touches at 1 point, that is when you have perfect square, and where it does not. So this is when you have a complex root. Does that make sense? So this is what it will look like. So this can also be positive if it was concave upward. All right, so why is this important? We don't need to waste time doing the demonstration. Now, because you can hear my computer, I'm going to play this for you. So please focus and listen. And confirm if you can hear my computer. Just do this.
We use sign diagrams to show the values of the variable x for which a function is positive, negative, 0, or undefined. For functions written in factored form, we can usually draw a sign diagram without graphing the function. In part A, the quadratic function is given in general form, so we first need to factorize it. There are no common factors and no special form, so we use sum and product factorization. 3 and minus 1 have product minus 3 and sum 2, so the quadratic has linear factors x plus 3 and x minus 1. Applying the null factor law, the zeros of the function are minus 3 and 1. So, on a number line representing the x-axis, we draw solid lines at x equals minus 3 and x equals 1. To determine the sign of the function when x is greater than 1, we substitute any number greater than 1. In this case, we choose x equals 2. Both factors are positive, so the function is positive, and we place a positive sign for x greater than 1. Alternatively, you could recognize that the coefficient of x squared is positive. This means the quadratic must be concave up, and so for large x, it must be positive. A linear factor that is raised to the power of 1 is called a single linear factor. The graph cuts the x-axis at the 0 corresponding to the factor, so the function changes sign at this point. X plus 3 and x minus 1 are both single linear factors. There is a change in sign about each 0, so the signs on the sign diagram alternate. In part B, the quadratic is already given in factored form. The only 0 of the function is 3, so we mark this point on a number line. To determine the sign of the function when x is greater than 3, we choose to substitute x equals 4. We see the result is negative, so we place a negative sign corresponding to all x greater than 3. Alternatively, you could recognize that the coefficient of x squared is negative. This means that the quadratic must be concave down, and so for large x, it must be negative. This function contains a linear factor which is squared. When a linear factor has an even power, the graph touches the x-axis at the corresponding 0, but does not cross it. There is therefore no change in sign at this point, and we place a negative sign for x less than 3.
Does that make sense? So you have two options. It's either you sketch it to visualize it, you factorize. Of course, you need to factorize to be able to sketch it anyway. But by just factorizing, when you have two linear factors, there will always be alternating sign. So if you can find one of them, do you know what alternating means? Like it goes up and down, right? So if you start with plus, the next will be minus, then the next will be plus, then the next will be minus, and so on. So you just like the author started with a number greater than 1 to be able to determine this part. You can choose to start with a number less than minus 3, like minus 4, like minus 5. Okay, it's your choice. So because they are linear factors, you just need to test one of them and use the fact that the signs are alternating to finish the rest. So if you test this and this is positive, you go back, this is negative, then this must be positive. No need to waste further time testing the others. Does that make sense? But when you have a square factor, from the picture we have seen before we came to this example, you could see that for square factors, the signs are always the same. So if the first one gives you positive, you know the other will be positive because it doesn't cross, it only touches. It touches and goes back to that sign. If it's coming from negative, it touches and goes back to that same negative. So the sign will always be the same. All you have to do is test for one of them. If I decide to use for 1, for example, because it is less than 3, then I still get what? A negative number. So once I put negative here, I know this is also going to be negative because this is linear factor in square form. Linear factor that is not in square form, two distinct linear factors, we have alternating sign. In square form, we have the same sign, okay? But this is because this is factorizable. If you notice it's not factorizable, you can use a discriminant to check if you have complex roots. If you have complex root, then it doesn't touch. Okay. In some cases, you might need to put it in the form that we saw here. And this, let me show you. These are the ones with linear factors, complex roots, which means when you do your b squared minus 4ac from the original form, you get less than 0, then you know that it doesn't touch. Now, if this a is positive, remember positive definite and negative definite? Remember that? So we can use that technique here. Okay? So if your a is positive, then it is positive definite. Because if your a is positive, it means it's in a minimum form. If it is in a minimum form and it doesn't touch the x-axis, then it must be coming from the positive y. Do you understand my point? If it is a minimum form of graph and it does not touch this, it must be coming from positive, going back to positive. So that's why when A is positive and it is a complex form, then it is a positive definite. And if it is a positive definite, every region is positive. Now, if A is negative, definitely is in form of a maximum, this form. If it is in this form and it doesn't touch, then everything is negative. Then you can have negative, only one negative on your sign diagram. Does that make sense? Now, what do we need this for? I'd like to give the two explanations together so you can get to work. Why do we need this? This is why we need it. Of course, you can always do this later based on what we have just mentioned now. If you are confused at any point, you need to write more clear notes, watch the video later. I want us to move as fast as possible. I hope I'm not being too fast, please. Can you all confirm? Am I being too fast? No. Okay, good. All right, let's move on. Now, how do we use this for inequality? These are the major rules, or let me say steps. It's not like a rule, like a law. These are the major steps you must follow. Make sure your right-hand side is 0. So every term should be on the left. Okay? Does that make sense? Make sure your right-hand side is 0. So everything must come here. So you should have something like ax squared plus bx plus c greater than 0 or less than 0 or greater than or equal to 0 or less than or equal to 0. You must have that form. That's the first thing. Factorize fully the left-hand side. Now, when you say factorize fully, you need to be sure if you can actually factorize in some cases. Now, look at this case. This can be factorized. Because when you bring this here and you do your b squared minus 4ac, you can get factors. Okay? Here also you can get factors. These are perfect square. But in some cases, you cannot get factors. So when you notice that you are finding it difficult to get the factors, just check your b squared minus 4ac if it is complex roots. Hello? Let me say that again. This factorized fully may not be possible in some cases. But before you waste your time, check b squared minus 4ac. If your b squared minus 4ac gives you a perfect square, in some cases like this, you can see the factors easily, right? Because it's a monic equation, coefficient 1. In some cases like this, you may not see it easily, but if you are used to factorization, you can actually see it easily too. But when you have questions like, I'll show you. Maybe when you have situation like, okay, maybe I write the steps here, please. Steps. Of course, you don't have to copy this exact step. You can actually just form a note from the book. Okay. Make right-hand side 0. Okay. Everything should be on the left. That is, make sure you have ax squared plus bx plus c greater than 0, greater than or equal to 0, or less than or equal to, sorry, greater than or equal to 0, less than 0. Make sure you have something like this. 2. Factorize left-hand side fully. Okay, before you can do that, check b squared minus 4ac, check if b squared minus 4ac gives a perfect square, in case it's taking longer time. Okay, if factorization is taking longer time, you're not able to figure out the factors. Okay, check if b squared minus 4ac is a square number. If b squared minus 4ac is not a square number, don't bother looking for factors. It means it's not factorizable. Okay, and most of them will not be factorizable if you have, let me see, I think in that case, you can just put it in the form of, what's it called now? Completing the square. In that situation, you can use completing the square. Okay, but since we are not actually after the exact, because if it doesn't touch it, this is what you are going to have. It means there's no solution. Okay, if we are talking about negative, if your inequality is about it, you will see in an example now. If the solution is when it is greater than 0, it means for all x. I will show you in some example now. Maybe I should move on, then I can chip in these things when I get there. Then it's easier for you to actually picture what I'm saying. Okay, let's look at these two examples. Please give me a thumbs up if you can hear the screen when it starts.
In this example, we need to solve quadratic inequalities. We have seen how sign diagrams can be used to show when a function is positive or negative. But first, we need to write all the terms on one side, so we are comparing an expression with 0. In part A, we make the right-hand side 0 by subtracting 2 from both sides. We now want to factorize the quadratic expression so we can identify its zeros. We write 3x squared as 3x times x. The constant terms in the linear factors must have product minus 2. We try the possible combinations until we find one which gives the correct middle term. We see the zeros of the function are a third and minus 2, and we use these to draw a sign diagram. If we substitute x equals 10 into the function, the result is positive. The linear factors are both single, so we place alternating signs on each interval of the sign diagram. To solve the inequality, we seek the values of x for which the quadratic is greater than or equal to 0. So, the inequality is true for x less than or equal to minus 2, or greater than or equal to a third.
Does that make sense? Do you know why they did that? So you look at your sign diagram, because this is what you are solving. So this, to solve this inequality, it is actually equivalent to solving this inequality. Do you agree? And from sign diagram, this is a sign diagram of when the function changes. So it means this whole function is positive when x is less than minus 2. It's also positive when x is greater than 1/3. So this is where the solution comes from, because we are talking about greater than 0. Greater than 0 means positive, so you don't need this part. If the inequality was less than or equal to 0, then you'll be talking about this, from minus 2 to 1/3. In that case, your inequality will be in the form a less than b less than c. Do you get my point? It will be combined inequality. Can you raise your hand if you understand what I'm saying? Okay, good. So you can see how the sign diagram enables you pick the answer directly. You don't need to go through any more stress. Okay? All right, let's move on. Next example.
In part B, we subtract 6x from both sides to make the right-hand side 0. We see that the left-hand side can be factorized as a perfect square. In this form, we see that the inequality cannot be true for any real x, since the squared term cannot be negative. We can also see this on a sign diagram. X equals 3 is the only 0. If we substitute x equals 10, the result is positive. The factor x minus 3 is raised to an even power, so there is no change in sign at x equals 3. The left-hand side is positive when x is not equal to 3, and 0 when x equals 3. So the inequality is not true for any real x.
Can you see? It means this has no solution for any real x. Okay? But if the case was greater than, what would you say? How would you conclude? If this was x squared plus 9 greater than 6x, what would be different? Anyone, quickly.
Wait, greater than and equal or just greater than?
Either way, let's just see. Does it make any difference? Greater than or equal to 0. Okay, let's say greater than or equal to 0.
Would it be true for all real x?
It will be for all. Understood? Lillian, do you get my point? Lillian?
Yeah, because if
Okay.
it's greater than, then it's not 3, right? Like
If it's greater than 0, it's not 3. Or what do you mean? No, we're talking about when this is greater than or equal to 0, or maybe when it is greater than 0. When it is less than 0, you can't have any solution. We can see that already, right? But when it is greater than 0, your greater than 0 includes, okay, it doesn't include 0. So I've left out 0. That's what you mean. Okay, I get that. So the reverse would be greater than or equal to 0. Yes. So does everybody understand what she's trying to say? If something is not less than 0, then it is greater than or equal to 0. If you want to do two options, right? For the 3, it will be greater than 0, less than 0, equal to 0. But we are not dealing with equal to 0. Let's just deal with this one. So you just say it is true for all. So if someone is asking, so x belongs to R, something like that, okay? It is true for x belongs to R, for any x belongs to R, okay? So that's that. So this is how we use the sign diagram to solve linear quadratic inequalities. Now, here is more applications to this, because I want to run through this quickly. Then I can send you the screenshot of the examples and assign the work that you need to do. After that, we are done with this, okay? So it's a very short idea. Now we can use this to also solve applied problems, and this is one of them. Find the value or values of k for which this function cuts twice. If it cuts twice, you know the form, right? If it touches, it means it's in form of a square. If it misses, then that's a complex. Hello, are you with me, everybody? Okay, so this is two linear factors, definitely. This is one factor squared, one linear factor squared, and this is no factor complex rule. Let's see how the solution goes. And please thumbs up if you can hear the voice.
In this example, we are given a quadratic function whose coefficients include an unknown number k. In fact, this value k appears twice. We seek the values of k for which the function has 2, 1, and no x-intercepts. Since the discriminant tells us the number of real roots of a quadratic equation, it can quickly tell us the relationship between the graph of a quadratic and the x-axis. We start with the coefficients of the quadratic and substitute them into the discriminant. We expand the perfect square and multiply out the remaining term, taking care that a negative times a negative is positive. Next, we collect like terms. Now, we need to identify the values of k for which the discriminant is negative, 0, or positive.
Now, you could see that before A or B or C is answered, the first thing was the discriminant. So you don't need to repeat this calculation 3 times, because everything you need to do here is about discriminant. All right? Cuts twice means distinct roots. So discriminant is greater than 0. Touches means equal roots, right? Discriminant is equal to 0. Misses the x-axis means complex root. Discriminant is less than 0. So in any case, we talk about discriminant. So you should do it just once. Then you can start with A. But if you put here A, it might be considered as part of A solution, and you need to probably repeat it in B solution, which is just waste of time. So before you even mention A, B, C as your answer, this is like a pre-calculation before you begin your ABC. Does that make sense? Let's move on.
Since the discriminant is a quadratic in K, we will need to solve quadratic inequalities. We therefore want this quadratic in factored form, so that we can use a sign diagram. 9 and 1 have product 9 and sum 10. So the quadratic has linear factors k plus 9 and k plus 1. Its zeros are -9 and -1. To draw a sign diagram, we start with a number line labelled with the variable k. We mark the two zeros, -9 and -1. When k is large and positive, both factors are positive and the discriminant is positive. The linear factors are both single, so we place alternating signs on each interval of the sign diagram. In part A, the graph will cut the x-axis.
Can you see all the calculation before we even started part A? This is to avoid unnecessary details in every question, since they are all common.
Twice if the discriminant is positive. From the sign diagram, the discriminant is positive when k is less than -9 or when k is greater than -1. However, we need to be careful here. We need to exclude the value k equals 0. Can you see why? If k is 0, the coefficient.
Can anybody tell us why? Why we need to exclude k is 0? Look at the function, look at the original function, and tell us why k is equal to 0 must be excluded.
If k is 0, then there's no x squared.
Good. And is that what kind of equation do we now have? What kind of function do we now have? Yes?
It'll become linear.
It will become linear. If this is 0, then you have ax plus b. Okay? Then it's no longer quadratic. That is why this condition needs to be included. So you have to be careful. If your unknown is in the coefficient, you need to remove 0 in the interval, because if the 0 is already removed from the solution, if this was -9 and this was maybe 1, okay? Remember, 0 is not part of the solution anymore. But because this is -1, remember, when you say k greater than -1, it includes k is equal to 0 as well. So that's why you need to remove that. But if this was 1 itself, it means you have left out 0 already. Then you don't need to add this anymore. Does that make sense? Karen, does that make sense? All right, let's move on.
Coefficient of x squared is 0, and so the function is not quadratic. It is a linear function, which will cut the x-axis exactly once. Note that this case does not fit the description touches the x-axis either. In part B, the graph will touch the x-axis if the discriminant is 0. So, the graph touches the x-axis when k equals -9 or k equals -1.
That is just solving when this is equal to 0. Okay? So that's just the normal equation. So that's easy.
In part C, the graph will miss the x-axis if the discriminant is negative. From the sign
tell
diagram,
us what that is before we play that. What would the solution look like? Just like this. Just like this, what will the solution look like? Give me in form of inequality, the range of K. Anyone? Let's try. Come on, Form 5. Try.
Can you ask the question again? I want to make sure I got your question right.
Okay, we want to know when the graph misses, right? You want to find the values of K. It may not be value, it could be range. Because value doesn't mean, like in this case now we got exact values of K. But here we got range of values of K. So find the range of values of K for which this misses the x-axis. We've gone through all the trouble. We have the number line, sign diagram. We have the condition of discriminants. We only need to write one step. What is that? It's in the sign diagram. Callista? Everything all right? Is it confusing so far? Or you're not just sure yet?
Is it where the entire sign diagram is either positive or negative?
But the condition is here.
Wait, Oh,
The graph misses the x-axis if it is below x-axis, right? The graph of what? The graph of the discriminant. Okay? So when does it give this? When do we get this from the graph of discriminant? Yes?
-9 smaller than k smaller than -1.
That's it. It's within this range. That's when it is below. Below 0 means when it is negative. Your answer should be deduced from here. Okay? Look at this. When it is greater than 0 means when it is positive. When this delta is positive. Delta is this function. Now, you started from the original problem. You decided to use discriminant because you know these are discriminant problems, right? Discriminant gives you a quadratic function. You decide to draw the sign diagram of the quadratic function delta. So you use delta to answer the question. Okay? When delta is greater than 0, that means delta is positive. You look at the sign diagram for the delta function. So below -9, above -1, except 0. When it is 0 means it is neither positive or negative. So you are looking at this mid interval, this one, the centers. Okay? This point in between alternating signs. And everybody see what I'm showing you? And when it is less than 0, you're talking about when it is negative. It is negative from this point to this point. Okay? From -9 to 1. So you have to write it in the form of combining equalities. -9 less than k less than -1. Do we need to put condition k is not equal to 0 here? Karen? Do we need this? Remember this additional condition. Do we need to put it in the third one?
No,
Why is that?
because 0 is not part of the range.
0 is not part of the range.
Graham,
Okay?
the discriminant is negative when k is between -9 and -1. So the graph misses the x-axis when k is greater than -9 and less than -1.
Can you see that? Okay. So please, let's take notes. Any question, please? If anybody is confused, so I can re-explain some stuff. So this will help you be able to solve this last part. Okay. So we have 20 minutes to the end of the class. I'm going to assign classwork, which should be sent to me on WeChat while the class is going on. So I need you to Draw sign diagram for the A, 1A, 1A. Okay, sometimes I need to change it. All right, let's pick 1A. Let's pick 1. Can somebody take note of this? Okay, take note of these numbers. Or you can put it in the chat. 1A, 1F, 1C. Let's start with that. Send that to me. Sign diagram for 1A, 1F, 1C. Wherever we stop, I will pick the next one as the homework. Okay, so let's just do some practice for the next 20 minutes. 1A, 1F, 1A, 1E, 1F, right? Did I say AEF?
C, you said C.
I said C. Oh my God, what's wrong with me? Sorry, because A and C look alike, so there's no point doing A and C. So can we use AEF, please? Okay, thank you. 1A, 1E, 1F. I put it in the chat, the group chat. 1A, 1E, 1F. So that's the first one. Send to me and we draw it together. So you send me one picture, okay? Shouldn't take time. Draw it together. I've sent in 2A, 2G, 2I. So send one together, send two together. Oh, okay. Don't worry, I'll be sending, okay, sorry. I'll be sending all this to the WeChat. I have the textbook, so there's no need. That's page 386. Can you still see the book? Can you still see the book on the screen?
Yes.
Okay. Okay, receiving messages.
oceans deep, my faith will stand, and I will call upon your name, and keep my eyes above the waves. When oceans rise, my soul will rest in your embrace, for I am yours.
Can you still see the book?
Yeah.
Okay, thanks.
Your grace abounds in deepest waters. Your sovereign hand will be my guide. My feet may fail and fear surrounds me. You've never failed.
Enjoy my music for free.
So I will
Maybe we can get piano from Nakita next time.
and keep my eyes above the waves. When oceans rise, my soul will rest in your embrace. For I am yours, and you are mine.
So I'll be sending the pictures to the group now so that anyone who is faster can move on to the next questions. Okay? So please bear with me if I move what you are looking at currently. So I'll send from the beginning so you can form your notes later.
And my faith will be made stronger in the presence of my Savior. Spirit, lead me where my trust is without borders. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made stronger in the presence of my Savior. Spirit, lead me where my trust is without borders. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made
So check your WeChat for any question you are looking for.
my Savior. Spirit, lead me where my trust is without borders. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made stronger in the presence
sending the review also just for your self-practice. I'm not giving you any work on it.
My soul will rest in your embrace. I am yours, and you are mine.
So that's all about the content of the book. So for anyone who wishes to do more practice, all right, so now I can check work sent. We'll close in about 5 minutes as planned. So, but I'll still continue to check your work, and I will message you personally if I notice anything wrong, or send the solution to you if you have not done it right. Then the homework for this, which will be done in Microsoft Word document like the last time. Please, I won't be locking my homework on Edmodo. So as you finish them, please just upload them. I don't want to put you under unnecessary pressure by telling you the deadline is this. Even the one that I set the deadline for weekend, if you need more than weekend, please go for it. Just make sure you turn them in. So if I set a due date, it's not going to be locked. It's just to remind you on Edmodo. Does that make sense? Mm-hmm. Can you still see the book? Okay. Lillian, I think I changed the questions to A, E, and F in question 1. But what you did is correct, but I changed the question so we can have different stuff, different types of question. That was the reason. Okay? I think you did another one entirely, but it's correct anyway, just letting you know.
Oh, okay.
Lillian, have you seen what I'm saying?
Wait, are you talking to me?
Have you seen the question that I'm talking about?
Like the E?
Yeah, I think you didn't do 1E, 1C, E, and F. I think you did something else.
Yeah, I did A, C, F, I think.
Yeah, we changed the C to E. I'm just letting you know. But what you did is right. Just take note next time. Because I changed it so I can have different categories of questions instead of the same linear factors. That was why I changed it.
Okay.
Okay. Okay, it's 12 o'clock. So I'll be closing the meeting and we all have all the, wait, oh, okay, Mr. Chang, sorry, I'm just getting your message. We all have the questions. Everything is sent to our group. So please continue to work. And when I'm done, I will send in what you need to do ahead of Friday. That will be considered a graded activity. Maybe a few questions, it won't be much. Between maybe 3 to 5 questions so that is graded and be recorded. All right? Understood, everyone? Okay. So I'll see you on Friday if there are no other questions. Mr. Cheng is not here. Hello, Ethan. Yes, Karen.
Can I ask for what are the questions we're supposed to do for question 3?
Question 3. I thought I put that in the chat.
Because I'm seeing A and H.
A and H, yes. Just A and
But-
H.
Is there H in question 3?
I thought there is. Yeah, question 3 is from A to O.
Oh, so it's not the one you were showing on the.
No. I was showing.
Oh, okay.
Have you seen it?
Yeah. I thought
Okay.
it was the one on the board.
Okay. So everybody got all the questions then. Any other questions, please, before we go? No? I'll see you on Friday. This dude has gone to the bathroom. I don't know. Maybe I need to wait. I'm going to copy this and just send it to our group. So just ignore the I'm going to the bathroom part. So that if you do not know what question to do, can you see it in the picture that I sent, the right-hand corner? So these are the questions you have to do. If anybody is confused about what question to do. Can you see my chat box on the right corner of the screenshot I just sent to you now? So use that to get whatever you need to get if you are confused on which question to do. All right. I'm just trying to wait for Ethan, so feel free to leave when you want to. I don't want him to come and, oh my God, everything is closed. What's going on? So I can at least explain to him what has happened. So I'll wait for him. So feel free to leave if you want to. The class has ended. All right.